As we have discussed that for the CNC we require the part programming, and for part programming we require some codes, G codes, M codes. Okay, how we write the codes, so that we will discuss basic part of the part programming in this lecture. So CNC programming basics, we have discussed that program structure consists of program start. The program start is the program number. The program number begins with the character letter O. Then program contains NC blocks, program end, M30 for main program, M17 for a sub-program. So the CNC program numbers like the O6219, O256, these are the how to write program numbers. CNC program blocks. So the program numbers start from O, then block number start from N is the address, block numbers from N00 to N999 like this. So this is the program number, and this block number starting from N. So for each block, block by block, the program will execute from block number 1. So block number start from N. So block number consists of number and words. Words are contents of a block. Block numbers are selected in the jumps from 10 for the purpose of insertion. CNC program blocks. So here you can see N001 block number. This N is 10. Then G is the proprietary code address. Then the coordinate system. Then feed spindle speed like this. So a block consists of one or more blocks. A word consists of a character, address, and a number. Every address has a certain meaning on which the corresponding number depends. So you can see G01. So G is the word, 01 is the number. So every this word consists of a character also. So every address has a certain meaning on which the corresponding number depends. So syntax regulations are there for CNC program. So the maximum block length must not exceed 4 lines. If maximum length exceeded, alarm 650 hours. So the maximum block length is not more than 4 lines. If it exceeds the limit, then the alarm occurs. So every block starts with a block number. After the block numbers, follow the G command. So BAUT consists of coordinates X, or in other controller U or W like this. So G command is the proprietary function, which is important for the toolpath functioning of the this machine. Like this, whether absolute dimension, incremental dimension, then movement in air or linear movement or rotational movement or feed rate or spindle speed like this. So these functions come in this. So after the block numbers followed the G command. But consider then coordinate system may be the X or Z or Y. And in the case of other controllers, it may be U, W like this. So for G02, G03, program interpretation parameter I and K are placed after XU and GW. F word means feed, thread pitch. S word means cutting speed, spindle speed. Then T word means tool address. M word means additional functions. So you can see the diagram. Absolute system is represented here. Absolute value programming. Already we have discussed in the previous lectures. So there are two types of coordinate systems in the CNC programming: absolute system and incremental system. In absolute system, all the coordinate of the point are represented with respect to a single origin. Absolute point. So you can see from 00 like P1, P0, P2, how the point coordinate varies. So for P0N, then P0 to P1 if you will go, then N is the block number, then J01 linear movement, then X is the coordinate of the point, next point, Z, then F means the feed rate, like this P1 to P2, then P2 to next point, like this absolute system is there. Now incremental system, the origin changes from step to step. For the next coordinate, next point, the previous point becomes the origin. So you can see P0 to P1 like this, then P0 to P1 to P2 like this. So coordinate system varies from point to point, previous point also. Mixed programming means somewhere incremental used and then somewhere absolute system we can use. According to the easy in programming, we requirement of the program, complex programming, we go for the mixed dimension, mixed programming, mixed coordinate system. So self-folding functions. So the majority of G and M commands and other words are self-folding, remain active until overwritten or deactivated. So self-folding means if they are not writing the next command or this next, then it will be self-folding. So G41 can be deactivated by using G40 command like this. So self-holding function means if you will not write the next command, then it will not be activated or deactivated. So G41 can be deactivated by using the G40 command. Like these self-holding functions are there. Then suppose G00 commands in block N010. So in block 010, G0 deactivated by G01. So now G01 will be active. So self-holding functions means if you will write the next command, then only it will be deactive. So G0 command is this linear movement, rapid movement in air. So now the tool is moving in air. So if you will add a G01 command, then G0 will be deactive only. Otherwise, it will work in air only. So the next command you will write, then only the previous function will be deactivated. So this is called self-holding function. Similarly, G01 is linear interpolation. So if you will write a G02, then G01 will be deactive. So like this, the holding functions work. So suppose in block number 0110, you are writing G00. So movement in air is taking place. Now in the next block 0120, you are writing G01. So G00 will be deactive, and now G01 will be active. In the same case, if you are writing the next block, suppose N0200, you are writing the G02, then G02 will be deactive, and G01 will be deactive, and G02 will be active. Similarly, if you will go for G03 in the next block, then G02 will be deactive and G03 will be active. In the same way, M03 is activated at N050 in the second block. So if you will write the M03, then after this, if you are writing M04, then M03 will be active. So in the same way, self-holding functions work. So two functions are interlinked. Suppose a spindle off and a spindle on. So suppose you are making the spindle on, then you will, for making off, then you have to write that this next M command in the next line, next block. So a spindle will be off. So in the same way, M03 is active now. Now in the next block, you are writing M04, then M03 will be active. So see the function of self-holding. Now reference points. You are referring the tool mounting reference point, workpiece 0 point, the machine 0 point. So you have to mention and in the program also. So M is machine 0 point. So unchangeable reference point determined by machine manufacturer. So machine manufacturer determines one machine 0 point. N is tool mounting reference point. Workpiece 0 point. W can be fully determined by programmer. So whatever the user are which are operating the machines can make the workpiece 0 point. It can be changeable. So this is workpiece. So workpiece means how the machining is carried out in the CNC machine. From this is showing here how the step by step of the tool is going to the steps. So G and M commands. So there are different commands like this. So suppose G00 is a rapid transfer in air movement. G01 is linear interpolation. So if they are the holding commands also, after making active of G01, G00 will be deactive. In the same way, if you are writing the G02 in the next block, G01 can be made deactive. Similarly, these are the basic commands which are used and which are very important to be remembered as well as for the competition point of view. So G00 rapid movement in air, G01 linear interpolation, G02 circular interpolation clockwise, G03 circular interpolation counterclockwise, G70 measuring in inch means unit of the dimension. Then G71 is measuring in millimeter. So now for M functions like this, G is the preparatory function, M is the miscellaneous function for additional settings of the M03 spindle on clockwise, M04 spindle on counterclockwise, M20 tail stalk back, M21 tail stalk forward. So this is the example of G0 rapid transfers. Okay, so absolute dimension of the target point coordinates N003, G90 is the absolute dimension. So for making it, adding the code G90, it will become the absolute, G91 incremental dimension. So block number, then G90, then G00 rapid movement of tool in air, X48 Z-6. So if you are writing a G00 command, the tool will move only in air to the X48 Z-26 means tool will run in the air only. So absolute X coordinate is 2 diameter is there. Then incremental dimension of the target point, the absolute dimension is y G90, then incremental is y G91. So you can see if you are using the G91, then this will be the incremental. So N0 G x minus 10 means the absolute dimension x48 is the with respect to origin, but if you go in the incremental dimension, so x minus 10 is the means you are moving the next point with respect to previous point. So previous point will be origin, so that is incremental dimension. Now, how can you represent G01 in linear interpolation? So, G90 the fluid dimension, G90 incremental system. So, in G0 block number, then G0 moment in air X39 Z2. Then G01 comes means G00 will be at active. So, now linear movement will be there X39 to Z0. Then G90, then G01. Similarly, for the G91, similarly G01, how can we use? G90 and 91 commands. So G90 is absolute with respect to origin. G91 is the with respect to previous point. So these are the basic commands which can be used here. So these are the basic references. Computer memory control at the Johnny Levny or other books like MP Gruber you can refer. Then Ibrahim Jaiti other books are there. So for basic practice also you can go through the website also. So in this way we have discussed that how basic parts of part programming, what are the basic functions, and how these uh, basic G codes, M codes can be implemented. Diagrammatically we have seen here. Okay. Now we will go for the second part in the next lecture, advanced part of the part programming, how to write G and M codes. Okay. Thank you for the patient listening. Thank you.